Good morning, guys. Just wanted to record a little video, just kind of going through a synopsis of a few of the things regarding the polynomial graphs, and then just add on a few additional things. Um, the key thing, I just wanted to go back and show you this table. You have to know your end behavior. When it comes to the two separate polynomials, again, the two things that'll determine your end behavior are going to be the degree and the leading coefficient. If it is of even degree, so that's the first thing you're going to look for. So even degree, we're talking about something where the leading coefficient is like an x squared plus x minus 7, something like that. As long as it's even degree as the highest power, then we would look at the even degree. For the odd, we're talking about something where it's a leading coefficient of something like 2x to the fifth minus 6x squared plus 3x. Who knows? But as long as the leading coefficient is odd in degree, it is considered an odd polynomial, odd degree polynomial. The next thing we look at is the leading coefficient. The leading coefficient is denoted by the a. The plus a means that leading coefficient is positive. The negative a meaning that leading coefficient is negative. Again, if it is even degree, it's going to go in the same direction for the for the end behavior. If it is odd degree, it's going to go in opposite directions. And again, the positive or negative a will be the thing to tell you which way it starts, whether it starts down, up, etc. So this is just a table. Again, if you didn't copy this in class every day, make sure you pause the video, copy this table. This is one of the key things you need to remember. The second thing we're going to do is just take this information and go and start a few of our examples. So this example right here, for those of you now, excuse my graph, is a little suspect. But just want to go through the things that at this point you should be comfortable determining from the graph. From the graph, you should be able to determine whether it's even or odd. That's going to come from you looking at the end behavior. If the end behavior is going in the same direction, that's immediately your sign telling you that it's even. If the end behavior is going in, if the end behavior is going in different directions, that's immediately your sign telling you that the end behavior is odd. So if we look at this graph for our do now here, this is going down on this side, and on this side it's going up. So therefore it's going in opposite directions. So we know immediately that this is odd. Now the next thing says, is the leading coefficient positive or negative? Now just a side note, for the homework that I just checked, a lot of you, when you were given the full equation, you're writing leading coefficient. Sorry, as soon as I start recording, I start yawning, guys, my bad. For the homework, we had problems like 3x to the fifth minus 7x squared. And when it said leading coefficient, some of you guys were just saying positive. I just wanted to indicate, if you are given the actual equation, you should not just be saying positive. You should not just be saying odd. If I give you a physical equation like this, then you should be saying what the actual degree is. Like the degree here is fifth degree. The leading coefficient here is 3. You're only going to answer these more generic questions when it's from the graph, where you can't give me the exact specifics, but based on the end behavior, you can tell me whether it's positive or negative, even or odd. So to continue, for this problem, it's asking you next for the leading coefficient. So is the leading coefficient positive or negative? In order to answer this, you also need to consider the end behavior. It's down up here. So let's go back to the table, and it's odd. And when it is down up, that means my a, or my leading coefficient, is positive. So I'm going to go back to my other sheet, and I'm going to say that my leading coefficient is positive. The number of, again, I should say real zeros here, because there can be a bunch of imaginary zeros. The real zeros are the x-intercepts, and this is just asking you for the number. So the x-intercept, there's 1, 2, 3, 4 of them. So there are 4. The next question for D says, what are the roots? So this means I actually want to know what these zeros, because again, remember roots, zeros, solutions, these are all the same thing. So you need to be comfortable with the term switching up. What are the roots, zero, solution? So the actual roots, now we're going to put the actual values. So they are -9. This here is -2. And then we have a +2. And then the last one here is 6. So these are the 4 roots. The next question says, is there any multiplicity? Now, this is a piece we spoke about in our last session, just to, again, reiterate the 3 situations with the multiplicity. If you have a multiplicity of 1, this is going to be when it passes straight through. When it passes straight through the x-axis. So something like this, both of these intercepts here, so this is 1, this is 2, both of these intercepts here have a multiplicity of 1. It's just going pretty much straight through. There's nothing special about it. Multiplicity of 1. A multiplicity of 2 is going to occur whenever we have a U. You can consider like a U-turn, like it started to cross and then it changed its mind. A U-turn at the x-axis. So when it has a multiplicity of 2, this is what we will be seeing. We'll see. Oops, kind of missed it at the top there. All right, let me try that one more time. All right. So if it has a multiplicity of 2, let me zoom in a bit more. These would be the situations where it has a multiplicity of 2. I'll indicate these with a blue dot. This would have a multiplicity of 2, and this would have a multiplicity of 2, because that's where it's making a U. It's like not passing through, it's just making a U at the x-axis. These other ones here, I'm going to mark them in yellow again. The yellow ones would have a multiplicity of 1. They're just passing straight through. Nothing special about those. But the blue ones have the multiplicity of 2, etc. So, and then the last type of multiplicity, there is one more, is going to be when there's a multiplicity of 3. Sorry, I just need to move this up a little bit first. So when there's a multiplicity of 3, what's going to happen is it lingers. It doesn't pass straight through. Doesn't pass straight through. And again, we're talking about passing straight through the x-axis here. So when it's going to be the 3 solutions, multiplicity of 3, it's going to basically take on this effect. It's probably not going to last quite that long as I've sketched it here, but it's going to definitely linger a bit, something like that, when it has a multiplicity of 3. It's not going to go straight through and keep going. So like this here is an example of a multiplicity of 3. Okay, so again, these are the things you need to look out for. Multiplicity of 1, straight through. This is one time. 2 is going to be our U. And then 3 is going to be our, like, linger at that point a little bit. All right, so let me go back up. So let's go back to our example here for this do now problem. So the question says, is there any multiplicity? So I'm going to go back and look at my zeros. So I'm going to look at the graph because you can't just determine that from the values over here. This one passes straight through. This one passes straight through. This one passes straight through. So I'm going to say 1 for all of those. Now the last one here, this one U-turns. So for that one with the U-turn, what we would do is we would indicate that this has a multiplicity of 2. Now you can just write in parentheses 2 times, something, but something needs to be indicated when something has a multiplicity. You can't just write it once. If you write it without indicating anything, it's assumed that it's only the one time. So you don't have to write once for the others. You only have to indicate when it is 2 or 3. Again, we're not talking about the maxes, extreme, or the mins at this point, so we'll ignore those pieces. The end behavior here is going to be down, up. And again, just be comfortable with knowing what that means in terms of infinity. And then the last thing here, the next thing here says to write the polynomial in factored form. So again, I'm just going to copy them down here so I won't have to draw an arrow so far up. So these are my zeros. And when I'm trying to write this in factored form, I'm going to write them in binomials. So it's always going to be binomials. Binomials is when it's just 2 terms. It's going to be binomials, and it's going to be the opposite of whatever the solution is. So when I am writing these as binomials with the opposite, it's going to be x. This is a plus 9, so I'm going to put a minus 9 here. Then I'm going to go to the next value. It's a binomial. This is a minus 2, so here I'm going to put a plus 2. It always has to be the opposite. The next one is going to be x minus 2, because it's the opposite. And then the last one with the 6, now again, I have to remember that that had the multiplicity of 2. So that'll be x minus 6, because it still has to be the opposite. But when it has a multiplicity that's not 1, we just put that power. So it has a multiplicity of 2, so that means we would put squared. And then we'll just put equals 0. Again, this is an example of what this could be simplest form. Simplest state in factored form. And then it says, what's the degree? For the degree, basically for our answer here, we would just go with looking at our powers here. 1, 2, 3. This is to the first, and the second. This would be 5th degree. Another way to also determine the degree, or the minimal degree, it's not the definite degree, but the minimal degree, is to look at the number of turns and then add 1. So the degree is also the number of turns you see in the graph plus 1. So if we look at our graph, there's 1, 2, 3, 4 turns. So therefore 5th degree. Okay. All right. So let's go down a little lower and just give you guys a quick synopsis here. So let's determine the characteristics from each graph. So just want to again go through these and make sure everyone's good at determining these. Is the function even or odd? You're going to determine that from the graph and the end behavior. If it's in the same direction, it's even. If it's in different directions, it is odd. Determining the number of turns, that should be something that you can easily distinguish from the graph. So we'll say the number of turns is x. The minimum degree is going to be the number of turns plus 1. So in this case, it would just be x plus 1. We're writing this out. Is the leading coefficient positive or negative? Again, that's something you should be to determine from the graph. By looking at if you know it's even and it's down, then you should know that it's negative, etc. So there's different that you should always also be able to determine from the graph. What are the zeros? Again, the zeros are the x-intercepts. And it says to have a multiplicity of more than 1. Again, we just spoke about those. You should also be able to determine that from the graph. It's a visual. Whether it passes straight through, whether it's a U shape, whether it lingers. And then what is the x-intercept? The x-intercept, everyone knows, that's where it crosses the x-axis. You should be able to determine that easily from the graph as well. All right, so let's do a quick few examples here. If you look at example 1, even or odd. Looking at this graph, you should know that it is even. Why should you know that? Because the end behavior is up, up. If the end behavior is in the same direction, it's even. Next, number of turns. 1, 2, 3 turns. So, 3 turns. Minimal degree. Minimal degree is the number of turns plus 1. So we're going to say the minimal degree is 4. Then it says LC, that's my leading coefficient. And here all we need to do from the graph is just indicate whether it's positive or negative. So here, because it's up, up, we know that it was positive. And then I'm asking you for the zeros and the multiplicity. The zeros are here at -3, -1, and 2. And then for the multiplicity, hopefully everyone acknowledges that the -1 has a multiplicity of 2. Again, sometimes I just put 2 times. I don't want, confuse anybody and make you think it's x's, so that's why I'm writing multiplicity of 2. Next thing I'm asking for is the y-intercept. Let me zoom in on it a bit if anyone has a problem with the visual. So here is our y-axis, our vertical axis. And the y-intercept is right here, and it's going to be at -6. And then the last thing asks you for the equation. And it says standard form. I'm never going to ask you for standard form, guys. I'm just going to ask you for factored form. And for this equation in factored form, you're going to write it as, again, x, it's binomials using the zeros, and it's always the opposite. So it'll be x plus 3. X plus 1. It has a multiplicity of 2, so that's squared. And then it's x minus 2. That's the factor form. All right, and this will be our last example here. For example 2, even or odd. Based on the end behavior, you should acknowledge that this is odd. It's going in different directions. Different directions is odd. The number of turns, 1, 2, 3, 4 turns. So that means our minimal degree, since we add 1, it's the number of turns plus 1. It's going to be 5. Our leading coefficient this time is going to be negative. And how do we know that? It's because it's starting up and then down for our end behavior. So for it to be down on the positive side, that means that it had to be a negative coefficient of the leading term. The zeros here are -2, -1. Then we have 0. And then we have 2 and 3. All of those have a multiplicity of 1. So since the multiplicity is 1, I don't need to write that. That's the given. And then the last thing is the y-intercept. The y-intercept here is going to be 0. And then it's asking you for this in factored form. Again, it's the opposite, so x plus 2, x plus 1. Whenever it is 0, is it wrong to write x plus 0? No, but saying I have, $27 plus $0 is useless. So you don't need to put that. If it's just the 0 if it's 0, you can just put it in front. So it just won't look weird in the middle like that. You could just leave it like that, but that looks weird. So I'm going to stick that in front with just the x. And then it's going to be x minus 2 and x minus 3 equals 0. All right, guys, hopefully that's enough for you to get everything done. Have a great day.